Hello, everyone, and thank you for joining with us here today. Someone doesn't mind just posting in the chat. They can hear us well. We can go ahead and get started. But yeah, I appreciate everyone joining here today. So today we're going to be covering the first part of our three-part series, where we really want to highlight the simplicity that can occur when you're using the right equipment for water quality instrumentation. And that's something here at Water Analytics we really believe in, and we've designed our Aquametrics products to really deliver that to you and ultimately to your end customers as well. Right, the people who are using the product on a day-to-day basis, they want it to be simple, they want it to work on a reliable standpoint, and we really do believe in that. And to help kind of go through that, we want to just showcase a little bit of, in 20 minutes, how you can really start to look like an expert in both pH and ORP for your customer base. So for those that don't know me, I'm Ryan Flood, and I'm the COO here at Water Analytics. And again, as I mentioned, we're really going to start to dive into some of the basics around water quality instrumentation with pH and ORP. Again, it's a 20-minute session. There's a lot more we can go into. We can give you some of the nuances, applications, any of that type of stuff. And at the end, I'll introduce you guys to our newest member of our sales organization. If you hadn't seen, we just posted about that on LinkedIn this morning, and we're very excited. And he'll be joining us at the end of this. But again, you can reach out, after this presentation to anyone here. We'll provide some contact information, and we're happy to dive into more details. Right, this is a true 101 style presentation. I want to start off with something really interesting. Right, it's that the pH sensors that we make and manufacture can and will last for long periods of time when they're maintained and taken care of. But even in harsh environments, right, when you say maintained and taken care of, people think, oh, well, I can't put it in a harsh environment. It's not true with our products. Right, here's a great example of a sensor that was running for over 10 years. Right, it as far as we're aware, is still running and delivering good results to the users on a consistent basis. That's where we really come with our instrumentation that works when you need it to. It's the foundation of the Aquametrics product line. And again, want to start off with that before really diving into just the simplicity of pH, because when you think about reliability and robustness and continuing to work, in a sense, that is delivering simplicity, right? And the fact that you don't have to wonder, is your sensor still working? Are you going to get good results? Are you going to get shut down? When your sensor just continues to work, especially when everything else fails, it allows you to really have a simple structure and simple measurement. And that's where we start off with, the fact that it's robust and reliable really helps deliver in that simplicity to the market. So things that can really help you impress your customer base, right? How can you get a sensor installed, set up, ready to go in minutes? Not always, able, right? If you have to wait for an electrician to turn on a controller, sure, there's going to be some environmental things that are going to throw a loop to you on that. But for the most part, right, if you've got this set up between wiring and installing, you can get that ready to go in just minutes. The other thing we're going to really talk about is one of the great benefits of our differential sensors, which is rebuild, don't replace. And then the last is, there's two measurements that can really start to assess the sensor health and really help you know when is it time to perform your maintenance, when is it time to perform cleaning, and when, eventually at some point down the road, when is it time to replace and get a new sensor. So we started this presentation with pH and ORP. And I don't mean this in terms of a pH and ORP sensor. Wanted to kind of highlight the two together, because when you think about pH, and again, this is going to be very, very high level here, really what the pH sensor is doing is it's going to be measuring the hydrogen atoms in the processed water. And that's the real simple high level view of a pH sensor, and it's using a glass membrane to do that. What about ORP? Well, it's just a different process electrode material selection, right? There's either a band or a disc in most applications. And with that, they're typically platinum or gold. And again, the the details behind the scenes beyond this point are really identical for the sensors, right? In this case, though, here we're measuring the electrons to find out your ORP reading versus the hydrogen atoms, and that's where you're getting your different measurements in the different sensors. But everything else starts to behave and operate very, very similarly. And so when we start talking about becoming an expert in installation and in support and getting your product up and running, being an expert in our sensors on pH allows you to be the expert in ORP and vice versa. Let's talk about mounting, right? Getting your process up and running, getting started is really critical, right? It's a great way to impress your customer, but it's also a great way to lose a customer early on if you're struggling to get through that process. So we make it really simple. There's two different wiring schemes, and again, pH and ORP, they're identical from a wiring standpoint. You can use the QR code here, or you can go to our website, or for our partners on the call here, you have access to our partner portal, which will give you access to the documents as well. We always recommend, you download it either to your phone or what device you have with you. So when you're on site, you're able to just go ahead and jump right in to installing it, right? In case you don't have internet access. But again, really simple. It's either going to be, your P60, R60 wiring or your PTX, RTX wiring. What about mounting, right? Mounting is really, really important with this, right? There's a lot of different ways in which you can mount it. We have a nice, unique T that allows you to be able to install the sensor in without having to get the cable all wound up. There's other options like wet taps. There's shields. There's jet cleaners and guards. Again, really, whatever you need to get that sensor installed correctly and safely, we can help you guys with that. So, something like the guard is really important to think about, because the core, as you saw from the previous slide, is that the electrode is glass. And if that gets broken, your sensor isn't going to work. So protecting that is really an important element. And then otherwise, it's a really robust and reliable sensor that's just going to keep working for you. Angles matter. So this is in all of our manuals. We like to always kind of talk about it. The real simple view of this is, if the sensor is not able to be installed correctly, you're going to get some bad readings. So this is something, as you guys walk into a facility, if you've already seen installation, you can really impress, a user and saying, if they have, let's say it's upside down, you can ask them, are you getting good readings on a consistent basis? And maybe they're not, and that's a good opportunity to help educate, that end user on how it should probably be installed, right? Easy for you to present yourself as an expert. This is one of the bread and butter of our Aquametrics differential sensors. Rebuild, don't replace. What do I mean by that? Well, it's the differential advantage. So process electrodes and differentials can't be poisoned, and the reference solution can be replaced. And this really comes from, as you can see here, is our salt bridge. And so that's a really great part of this, is you can take this out, and again, depending on how inclined you are with tools, anywhere from 1 to 5 minutes, you can take the salt bridge out, replace the reference solution, and put a new salt bridge back on, and your sensor is ready to go. So for the most part, right, that's like a $30 replacement, instead of having to replace a whole sensor that could be several $100s. And that really allows these sensors to last for years upon years with really minimal maintenance, right? Again, 1 to 5 minutes to get you going. But there's other advantages with the differential sensor, where it can also help eliminate some of the ground loops. And it's also going to give you a little bit more stability in some of your readings. But again, the real value with it is that sensor is going to last for years, not months, like some of the combination sensors out there. Calibration and electrode health. So this is where, a lot of times it's really important to be thinking about how is your sensor working, and you want to get it up and running. So I just want to walk through a quick little demo here on one of our 2250 series controllers. So you'll start off your process, it's wired up, it's working, and you don't think the sensor is reading well. So you want to perform calibration. Pretty straightforward. You go to the screen, you start off with your calibration, and you're going to choose the number of points. We typically always recommend a 2-point calibration. You can go with more points if you want as well, but 2 really is the sweet spot. It's going to give you some of your best readings. And then from there, you get to choose auto calibration or manual calibration. The auto calibration is a really nice feature of our 2250 series, and it helps detect what reference solution you're putting the sensor in. And this can be really good because if it can't detect it, it can indicate that your sensor may need more than just calibration, right? It may need that new salt bridge, may need a little bit of cleaning. And that's an early indication that you may want to do things a little bit differently. And you don't have to then waste your time with performing the calibration. You can relook at the sensor first and see, is it in good health? So there's your first indication of, is your sensor in good health? So then you're going to move into, let's say we've chosen the auto. You're going to put it in the first buffer solution. Once it's in there, you're going to go ahead and hit enter. It's going to detect what that is. Again, in this instance, it's detecting that it's 10. If it is in 10, you're going to hit enter. Again, like I said, if it's not, that's a good indication you should be performing some maintenance. Then you're going to go ahead and put in the second buffer solution. It walks you right through this, which is great. And then here, I didn't update that screen. It should say, put it in buffer solution 4 or 7, one of the other two standards that we have. Once it detects that, you're going to go ahead and hit continue. And then it's going to go through it. And this is really everything you need here at the end. You're going to look at your slope and your efficiency and your offset. And what we would really kind of highlight here is this helps you identify how your sensor is behaving. So we look, so in terms of efficiency, about 78% and below is really where you want to start looking at from a maintenance standpoint of maybe replacing the salt bridge or the reference solution, performing some of that cleaning. Anything above that, you're going to be getting good readings. And it really comes down to what's the level of accuracy you want to be getting and the level of resolution you want to be getting across the range that you're measuring. Now, just because it's at 90% efficiency, 90% efficiency is still really strong and can get you good readings. When you go through your process more and more, you can see how consistent these numbers are. As your efficiency starts to go down over time, that can also be your early indicator that you may need to perform some maintenance sooner rather than later. We make it easy for you, right? As I said, with calibration, 2 is good for you, right? We have pH sensor solutions and we have ORP solutions available for you from our factory. You can also get them in other places if you'd like as well. It's really just having a good reference solution that you can believe in, right? So for pH, you pick, again, the 4 and the 10 or the 7 and the 4, and you can perform your calibration. And again, you're up and ready to go. The nice part about the pH 7 buffer solution here as well is that's also what we use in our reference solution. So there's other sensors on the market that may just use like a KCl reference solution, and you'll need to keep that on hand. For us, one of our advantages of the differential sensor that we make and manufacture is the reference solution is just simply pH 7. So that's what we kind of always say when you're doing 2-point calibration, pick 7 as one of your solutions, because you're already going to need that for your reference solution as well. And it really just helps cut down the number of materials you're going to need to perform calibration and maintenance. Dirty sensors. This is where things can really go wrong. So when you look at a sensor like this and you say, hey, it's just not calibrating, it's going to be an issue, right? There's only so much you can do with calibration. And then if you have a sensor like this, it may just be time to clean. Again, it's really based off of your application. For some people, they can get some readings off of a sensor still like this, and they're happy with it. But if you need a higher level of resolution and you're struggling to perform the calibration and your sensor looks like this, it may be time to clean. So how do you keep it clean? Pretty simple. You can brush or wipe it. You can add a little bit of soap into that as well, especially if there's oil in that application. If you have DI water on hand and it's not that harsh of an environment that it's installed in, a simple DI rinse could really work. If you're in some of the more harsh applications, sometimes a weak acid is going to be what you need to just get it up and running, ready to clean. And again, if you look back to that previous picture, you can really tell, does it look clean? Is it ready to go? But then it really comes back to as you go through that calibration. If you're struggling to perform calibration and you do the cleaning and then it's back up and running, there's your answer. You've cleaned it well. Sometimes it's worth giving that little extra, with a soft bristle brush or a nice clean wipe, and you give it a little bit more. Again, be careful of the glass, and you're back up, ready to go. So what do the numbers mean for calibration? So as we mentioned before, the efficiency. So about 78 to 122, because you can be on either side of that spectrum from the efficiency standpoint. That's when you want to start saying it's time to maybe clean the probe. If you have an offset that's a little bit too far, maybe it's time to replace the reference solution. Again, that could be contaminated, or the salt bridge, its junction could also be clogged. And again, you just need to clean it. So if you sometimes also see some sluggish behavior, the salt bridge can also be a good indication. And again, when you're thinking about a 1 to 5 minute solution to get yourself back up and running, it's really easy to just pop that salt bridge off, replace the solution you're already going to have on hand for calibration, and you're ready to run and back in business. And that's, again, where we really stand by our sensors are going to outlast other probes in the market because of this differential technology, and that they can just keep working. They're made to just keep going through it, even in those harsh environments. As you can see here, here's another harsh environment. It's in and day out. It's performing exactly as you want. And if you perform that regular maintenance and you perform your calibration, you're going to get great readings for a long life of that sensor. And that brings us to the other kind of exciting news we have here today, which is introducing Mark G. Referring to him as Mark G here, for those that know the water analytics company, you know our president, Mark Spencer, as well. And so now we have to differentiate between the two different Marks. So had a little fun and you know, call him Mark G here. Mark's got 20 plus years of experience in the water industry and filtration industry, and he's joining us as our business development manager. And I put a fun little picture in here from when a little chat GPT of just some of the fun hobbies that Mark has, and he also used to run a logistics business driving a truck. So showing that he's coming back to the water industry with us, having a little fun with it. But without further ado, here's Mark G.
Thank you, Ryan. I really appreciate it. Thank you for the warm welcome. Definitely excited to be part of the water analytics group. And hoping I'll be in touch with a lot of you and supporting you with all of your needs. It's impressive to be part of this company because, obviously there's a great team. I've only been here a month, and I can see the support not just to the customers, but to myself as I get acclimated. And I appreciate being put in a position to be able to support our customers with the information that I'm able to learn here beyond what I've basically acquired over my 20 years of experience. Just looking at some of the things that you talked about that kind of reinforce, the value that water analytics brings. You can see from the presentation that was just provided on differential pressure sensors that we provide a product that is simple to use. We provide a product that is very durable, and you're also dealing with a company with a great history of innovation. And then from a people perspective, you're always gonna find a person on the phone or email who's going to support you with all of your needs, may they be technical or commercial. So I'm excited to be part of the team, and I'll be looking forward to hearing from you guys, and also I'll be reaching out so that we can go ahead and collaborate together and meet the objectives of going out there and providing proper analytical instrumentation that your customers are going to be able to use to meet all of their measurement needs.
Yeah, that's great. Yeah, welcome aboard, Mark. And as Mark said, you want to learn more, you can call and get a human, right? We have a whole team here ready to help you. We put a few numbers on here as well. So my contact information and Mark's contact information here as well. You can call our general line. It's going to go to a person. We have a nice little telephone tree, so almost always you're going to get a person. If you don't, leave a message and we're going to get back to you as quick as possible. But you also have access to some of the emails here as well, like our info account and our support. Anything you need, technical support, orders, any of that, we're happy to help you guys, and we'll, as much as possible, connect you with a person and get you ready to go. So yeah, we appreciate that. So with that, you want to open up to a little bit of Q&A. So you should see there's a little Q&A in the Teams bar up at the top. you go ahead and post any questions you may have for us, and we can go through. So I don't know, Mark, do you see any questions coming through here as well?
Well, let's give everybody a couple of minutes to think up their great questions, and then we'll go ahead and present them. But while we're waiting, I just want to go through a question I have myself, which was
fantastic.
You talked about mounting options for a differential pressure sensor, and you talked about hot tub and inline mounting. Can you tell us if the sensor can be used in a submersible application?
Yeah, no, it's a great question. So yes, it's really going to come down to what are you trying to do. If it's really your facility that's going to dictate what type of installation. So a great example of a submersible that we do a lot of is the aquaculture industry. So a lot of times people are going to actually put these sensors directly into the aquaculture tank with the fish. And it's going to be right into there, and it's fully submersible. So these sensors have worked very well, fully submerged. So kind of beyond the IP68 rating, and very successful with that. And again, we have other accessories for something like that, where maybe you want a guard, right? Maybe you don't want a fish bumping into that glass electrode. We have little guards on that can help protect the electrode as well. And also, if you have an operator that maybe just throws it over, it does happen sometimes. You want to protect it. We have other things that can help with that as well. Yeah, great question.
Great. Thank you, Ryan. And let me just take a look here. Looks like we have a question from Josue. Josue wants to know, it looked like he's happy to know that the sensor is serviceable, but can you give us an idea of overall cost of ownership?
Yeah, it's a good question. So I know it's kind of digging a little into price. Where we kind of look at it, it's really going to depend on the level of accuracy and resolution you're going to want on a continual basis, and what type of application you're in. So if you're in some of those harsher environments, you are going to need to replace the salt bridge and the reference solution and perform some of that cleaning a little bit more often. But that, again, just allows you to get that sensor back up and running. And compared to other options in the market as well, they're going to be running through that same type of environment. But our salt bridge, the list price for that goes for around $30-ish. So when you think about it, if you're doing replacements, maybe 1 to 2 times a year, you're looking at your maintenance cost on that. It's really only going to be about $30 to $60 a year. And again, you'll have some calibration solutions. So depending on your frequency of that, you could say that overall, your cost of ownership of a sensor, it can really be under $100 a year if you're performing a good amount of maintenance.
Okay. So basically, what you're trying to say is, rather than replacing the sensors are serviceable.
Correct. Yeah, and that's one of the big advantages. You don't have to keep replacing the core of the sensor every year, which is the more expensive part. You're just replacing this quick consumable. Again, as I said, 1 to 5 minutes. Again, if you're fast, that's maybe something you give a little competition to your coworker and see who can swap that salt bridge out faster, and see if you can even get done in under a minute.
Oh, okay. Yeah, that's again, goes to the value that our sensors provide. So you can see that when you're thinking about value, overall cost of ownership, you get to use a robust product for a much longer period of time. Let's take a quick look here. Looks like there's a question in regards to calibration. How often do you need to calibrate these sensors?
Yeah, another good question. And unfortunately, this one also is it depends on your application and your process. The recommendation we kind of give to a lot of people is, if you're not familiar with your application and your process and how often you may want to calibrate, is check it on a more regular basis. So it's pretty easy, right? You calibrate it once. Let's say, again, as I recommend, using pH7 as one of your calibration solutions. Instead of performing calibration, let's say after the end of the first week or after a couple of days, you can put it back into that pH7, see where it is. And if that's an acceptable amount of drift to you, you don't need to perform the calibration and you can get going. If your process is pretty repeatable, what you can start to build out is a calibration schedule for yourself. So we have some people, right, that are calibrating pretty consistently every week. We have some people that go weeks or months without calibrating. It's really going to depend, again, on their application and their needs. But the other big kind of caveat that we'll always kind of have to give is sometimes it doesn't matter what we say or even what you guys do from a testing. If you guys have regulations that say you must calibrate every month, you're going to just have to calibrate every month. Even if it's reading spot on, you'll need to perform that from a regulatory standpoint. So it is important to understand what your regulations are at any given time.
Okay, great. And just talk about the fact that we also provide the buffer solutions that are going to be required to carry out the calibration.
Yeah, so we have those buffer solutions available in stock. So one of the nice parts of our sensors here is we do make and manufacture them here at our office in Andover, Mass. And we test and calibrate, or we test every one of our sensors and we calibrate our smart sensors using pH buffer solutions that we have in-house as well. So you are able to get from us the exact stuff that we're calibrating and testing it in, and that is a recognized standard for pH and ORP.
Okay, great. I don't really see any other questions on here. Let's give it a few more minutes, but let me throw another question at you.
Sure.
You talked about how robust our product is, and obviously we stand behind our product. Let's talk a little bit about what our warranty policy is on our sensors.
Yeah, so as you know, we really do stand behind our product, right? It's one thing to say our products last and are reliable, and sure, everyone's going to talk about how great and reliable their products are, but we really stand behind it here with the Aquametrics products, and we have one of the best warranties, I think, in the market of a 2-year warranty for our pH sensors. And it's because, again, they're going to last for that long period of time. They're going to give you the results that you're looking for. So we truly do stand behind the performance of our sensors.
I think everybody's going to agree that that's a pretty impressive warranty policy, considering the fact that a lot of these products are going into really harsh environments, wastewater, chemical processes. So yeah, that's definitely good information for the customers and the people who are out there supporting their customers with our product. I don't really see any other questions, so I think that's it for the question and answer section for now.
Yeah, well, I appreciate it, and thanks for moderating with that. And yeah, and again, thank you guys all for attending today. So we're going to be, this has been recorded, and we'll have this up shortly on our YouTube channel. So again, if you guys don't know where that is, again, feel free to reach out to our information here. And we'll also be sharing this presentation on our partner portal for those of you who are our partners. You'll be able to have access to this if you want to perform any other training. But again, reach out anytime. We're always happy to talk about that, and especially with Mark, joining us here. Feel free to call away and then and test him out on his knowledge of pH. He's 2.5 weeks in here, and he can test and calibrate these sensors on the fly and ready to go. So yeah, again, we appreciate you guys taking the time out of learning some pH and ORP stuff with us today. Again, this is part of a larger series, so we'll have our next one on February 24th. We will be doing Simplify Conductivity, very similar kind of theme, but we're talking conductivity. And then on March 24th, we'll be doing, again, a similar one, but with controllers, really kind of getting into what you need to understand from a simple standpoint, because controllers can be simple. They can also be a little bit complex. We can simplify that all up for you and make it easy. So that's kind of our theme for this quarter. And if you guys want to learn more about how we can simplify water quality instrumentation for you, please reach out. Otherwise, have a great rest of the day, and we'll talk to you all soon. Take care.
Thank you.